In this video, we are looking at vectors. A vector has both magnitude and direction, and a scalar has only magnitude, so it has no direction. Distance is a scalar. So the distance could be 10 meters, but that doesn't tell you what direction it's going in. It's just a number. It's just 10 meters. The vector is called displacement. So displacement is the same as distance, but it's also got a direction. So if we've got a straight line, the distance could be 10 meters. That doesn't tell you if you're going forwards or backwards along that straight line. Displacement could be plus 10, which would be going forwards, or minus 10, which is going backwards. So distance is the magnitude of displacement. Another example of this is speed. So again, you could have 10 meters per second, but it doesn't tell you what direction it's going in. And if it was in a straight line again, the velocity, which is the vector, could have plus 10, so 10 meters per second forwards, or minus 10, 10 meters per second going backwards. The speed is just the magnitude, so the magnitude of the velocity. Acceleration is a vector. So acceleration has a magnitude and direction, and we don't have another word for the scalar. We just say the magnitude of the acceleration if we only care about how big it is, not the direction it's going in. Here we have a question. The velocity of a car is 12I minus 8j meters per second. So it's velocity because it's got a magnitude and a direction. So it's got a size, and we know the direction it's going in from these i's and j's. It's going 12I every second. It's going 12I, so 12 along the x-axis, minus 8j, so 8 down the y. So every second it's going along 12 down 8. We want to know the speed. So the speed is just the magnitude, and we can work that out using Pythagoras. So it's just how long this line is. So the speed is the magnitude of the velocity, and we work that out using Pythagoras. It's just how long is the line? How far does it go every second? So from here to here. So use Pythagoras. It's the square root of 12 squared plus 8 squared. And the square root of 12 squared plus 8 squared is 4 root 13, or 14.4 meters per second. So every second it goes 14.4 meters. That's the speed. Part B, find the angle the direction of motion makes with the unit vector I. So the vector I is the one in the x direction. It's that way. So what angle does it make? That's this angle here. And we can work that out using SOHCAHTOA. So we've got the opposite and the adjacent. So we use tan. Tan x equals the opposite over the adjacent, TOA, 8 over 12. So the angle is our arctan shift tan, 8/12. And that is 33.7 degrees. One for you to try. Pause the video, give it a go. So the velocity is 10I plus 14j meters per second. So every second it goes 10 along the x and 14 up the y. So we use Pythagoras to work out the hypotenuse. So it's going to be the square root of 10 squared plus 14 squared. That will be the speed. And we get 17.2. So 17.2 meters per second is the speed. Find the angle the direction of motion makes with the unit vector I. So again, the unit vector I is that way in the positive x direction. So it's this angle here. We've got the opposite and the adjacent again. So it's tan again. Tan x equals 14 over 10. So we want arctan of 14 over 10. And we get 54.5 degrees. Here's another question. The displacement from A to B is 5i plus 8j meters. From A to C is 12i plus j meters. Find the distance from A to B. So we know displacement along 5 up 8. So 5, 8, that's the displacement. The distance, we use Pythagoras. So it's just how long is this yellow line? How far is it from A to B? So Pythagoras, the square root of 5 squared plus 8 squared. And we get 9.4. So 9.4 meters from A to B. Part B, find the displacement from B to C. So we don't want the distance, we want displacement. So it's going to be in terms of I and j, because we need to have a direction. So how do we get from B to C? We can go backwards along A to B, and then forwards along A to C. So it can be minus 5i plus 8j plus 12i plus 1j. So minus 5 plus 12 is 7. Minus 8 plus 1 is negative 7. So it's 7i minus 7j. One for you to try. Give it a go. The displacement from A to B is 5i plus 4j meters. The displacement from A to C is 8i minus 3j meters. We want the distance A to B. So again, we've got a long 5, up 4. To find the magnitude, we use Pythagoras. So the square root of 5 squared plus 4 squared is 6.4 meters. Find the displacement from B to C. So to go from B to C, we're going to go backwards along A to B. So minus the 5i plus 4j. And then forwards along A to C. So plus 8i minus 3j. So minus 5 plus 8 is 3. And minus 4 minus 3 is minus 7. So it's 3i's minus 7j's.